Okay, here's the setup for the first laboratory. It's very straightforward. We have three components involved: a capacitor, which is used in another part of the circuit, the inductor, looks like a resistor but it's an inductor, and then the resistor here. You can see that we're not even using a proto board in this setup. So the input source, the red wire, serves the inductor, and then that goes to the resistor to ground, all three grounds here. Now we're using scope probes because we're working at a little higher frequency. Channel 2 is connected to the source, and the reason why is that this scope here prefers to trigger on channel 2, and you always trigger on the strongest signal, which in this case will be the source. Okay, the output, which is channel 1 across the resistor, will be changing. So with this, using this method, the red signal will always trigger channel 2 properly. Okay, now we're ready to turn on the equipment. Okay, so we have two pieces of equipment to use: the scope, turn that on, and the arbitrary waveform generator. We'll set up the arbitrary waveform generator first. It defaults to 1 kilohertz, so we're going to set that to 1 megahertz. The easiest way to do this is just hit enter number 1 and then megahertz. Okay, now we also need to set the signal level, so that's on the level here, and we're going to, it defaults to 100 millivolts. We're going to set that to more than 1 volt. In fact, we're going to go to 1.4 volts, which will allow us to do RMS values. So now we can see the signal is triggering on the scope. So we can press auto scale and try trigger properly, so we'll press it one more time, and there we see our signal. In order to get a good clean signal, I like to push the acquire button and set sampling, which in this case is called averaging, and we'll leave it set to 128 right now. You can adjust it down if you want to 64 or 32, but 128 is nice, and we'll use that. Alright, we're not getting a signal currently on channel 2, so there's channel 2. We'll dial it in, and there's the two signals. We'll adjust the two signals so they're centered around the 0 point, the point in the middle. This gives us the greatest accuracy for the signals that we'll be reading. By the way, in this case, when I select channel 2, you'll see that the vernier button is on because it was on in the last setup. I like to use the vernier to give us a little more adjustment. If you don't use the vernier, you can see the signal changes quite dramatically. If we press the vernier, it changes more slowly to allow us to adjust it a little finer. Let me check channel 1 here. Vernier is on, so now we get both signals. Alright, now we want to set up the measurements. Okay, so we'll click on quick measurements, and these have already been set, but RMS 1, RMS 2, and then the phase between them. I'm going to adjust the RMS value on the function generator to be greater than, to be 1 volt at least. So we'll increase this up. You can see that we exceeded the range of the scope, so we'll need to readjust these signals back down. Alright, now we're ready to record measurements. Okay, so the first setup we're going to do is figure it out what the frequency is for 45 degrees phase shift. You can see it's already very close. The little kind of compression you see when the frequency is adjusted is the averaging. So need to go the other way. 48 degrees, a little too much. 900 kilohertz is too low. So we're going to go back up to 1 megahertz and then move the flashing over so we can adjust a little finer. 44, 45, pretty close there, 40. Can be a little challenging to get, but as long as you're within a half a degree of 45, that's a good starting point. 45.6. And if you want to do even finer resolution, you can select it closer. And that's pretty close, 45.2. I like to press the stop button up here once I've got things set up, and that freezes the screen, so now the numbers aren't changing and you can just record them directly. Channel 1 is 1.153 volts RMS, channel 2 is 1.6338 volts RMS, and the phase is minus 45.3. Just record that into your spreadsheet, and the frequency, which in this case we'll consider our critical frequency for this RL circuit, is 1.032 megahertz. So record those values. You will use this critical frequency to set up your other frequency measurements, and that is really the same measurements, just new frequencies. For example, if 2 megahertz was one of our points, we'd hit enter 2 megahertz. You have to go and unfreeze the display, of course, and you can see that the signal dropped down. This being a low-pass filter, the output signal drops as the frequency increases, and we see the output signal. If 4 megahertz was our next signal, hit enter 4 megahertz, and you can see the display change and the output drop even farther. That's about it. You just repeat this many times in this laboratory.